In this video, we are going to discuss various types of medium access control protocols for wired LANs, and in the next video, we will concentrate on MAC protocols for wireless LANs. Network links can be divided into two categories: point-to-point or dedicated, and multi-point or shared links. In a dedicated link, all of the bandwidth of the link is going to be allocated to the communication of two nodes, such as the old telephone systems, in which if two persons are talking to each other on the phone and a third person calls one of these two people, he will hear a busy signal. A busy signal means that the network link is busy and you should wait until it becomes free. In a broadcast link, which is mostly used in local area networks, multiple nodes share a link among each other. They compete to access the link, and if two nodes send their signals at the same time, a collision is going to happen, and as a result, stations should retransmit their signals. Retransmission is going to waste time and bandwidth, and network protocols attempt to minimize it. Medium access control protocols' task is to prevent collision by determining who gets to use the channel when there is a competition for it. The data link layer in TCP/IP is divided into two sublayers: logical link control, or LLC, and medium access control, or MAC. LLC handles tasks such as error detection, correction, and framing, but the MAC sublayer controls access to the shared medium. MAC protocols can be divided into three categories: random access protocols such as Aloha, CSMA, control access protocols such as token passing, and channelization protocols such as FDMA and TDMA. The simplest form of allocating a simple channel among multiple competing users is to chop up the frequency band into small portions and give each user a portion of the band. As each user has a private band, there will be no interference among users. This is a static method for allocating frequency band. When there is a small and constant number of users, this method works efficiently. For example, in FM radio stations, each station gets a portion of the FM band and uses it to broadcast its signals. However, when the number of senders is large and varying, FDMA presents some problems. For example, if the spectrum is cut up into n parts and fewer than n users are interested in communicating, a large piece of the valuable spectrum is going to be wasted. And if more than n users want to communicate, some of them will be denied permission for lack of bandwidth. The other static method is the TDMA, in which time is divided into n equal size portion, and each user will get a portion of the time frame. In TDMA, each user will get the entire frequency band for a limited period of time. It is very similar to FDMA, and it has the same issues as FDMA's due to its static approach. In cellular phones, a combination of FDMA and TDMA along with other methods such as CDMA is used for channel allocation for mobile users. The first MAC protocol, called Aloha, was developed in Hawaii in the 1970s. It has two types: pure and slotted Aloha, that fall under the dynamic MAC protocols. The basic idea of an Aloha system is let users transmit whenever they have data to be sent. When a station sends a frame, it listens to the channel to see if the frame gets to the destination. If a frame faces a collision halfway through the transmission, the transmitting station waits for a random amount of time and then transmits its frame. Waiting time is random to avoid more collision from happening. The chance of collision is high because the stations are free to transmit whenever they want. For example, in this picture, there are multiple overlaps between frames which result in collisions. In order to double the capacity of the Aloha system by lowering the chance of collision, slotted Aloha was proposed in 1972. In a slotted Aloha, the time interval is going to be divided into discrete intervals called the slots. Each interval corresponds to one frame. Unlike pure Aloha, in which users were allowed to send at any time, in a slotted Aloha, users can send data at the start of the time slot. If a user has data in the middle of a slot, he has to wait until the start of the next slot. This method lowers the rate of collision by controlling the transmission time. However, the chance of collision is still high. For example, when two stations start their transmission at the start of the same time slot, a collision is going to happen. In both pure and slotted Aloha, stations transmit their data without checking the channel in advance. They both first send and then check for the collision. This issue is going to raise the rate of collision. To resolve this issue, a new protocol called Carrier Sense Multiple Access or CSMA was developed, which first checks the channel and then transmits. If the channel is free, it will transmit its data. Otherwise, the station will wait for a random amount of time. In CSMA, if two stations sense the channel to be free and start transmitting at the same time, their signals will collide. Another improvement is for the stations to quickly detect the collision and then stop transmitting in the middle of a transmission. This method saves time and bandwidth. It is called Carrier Sense Multiple Access with Collision Detection, which is mostly used in wired LANs such as the Ethernet.